Hooks, guarantees, and code, not vibes. Playlist 05. The stack ribbon lights up. Layer 3, the surfaces. Today we make the agent loop honor a rule it can't talk its way out of. On the left, a system prompt, never refund more than $500. On the right, a code gate that just refuses. Both say the same thing. Only one is a wall. A determined user can paraphrase past the prompt. They can't paraphrase past an if statement. Here's the agent loop with only the prompt in place. The user pushes. The model caves and emits process refund amount 750. It passes straight through to execution. The ledger ticks down. The money is gone, and the prompt never stopped it. Now we drop a PreToolUse hook directly onto the path between ToolUse and RunTool. Solid hardware. It intercepts before execution and it always fires. It isn't a suggestion the model can reinterpret. It's code. Rerun the 750 call. It hits the gate turns red, blocks the tool, and sends back structured JSON, decision block, reason policy cap, not retriable. The model isn't punished. It's told no with a reason. It reasons about it and proposes a compliant $500 refund. Code held the line. Pull back. Hook events aren't a flat list. They fire at 3 cadences. Per session, once when a session starts and ends. Per turn, once per user prompt. Per tool call, every time a tool runs. Pick the cadence that fits the problem. Audit logging, per tool call. Project context injection, per session. Blocking a prompt before processing, per turn. Start with these 4. Pre-tool use, post-tool use, session start, stop. Anthropic's docs note they cover about 80% of real use cases. The other 11 plus are for specifics. Sub-agent events for multi-agent observability, pre-compact for context management policy, permission request for granular control. Build for the 4. Reach for the rest when you need them. A hook is not only a shell script. It can be one of 4 handler types: a command, a shell script, which is about 90% of real-world use, an HTTP handler that posts to a URL for team-wide rules, a prompt handler that asks Claude a yes or no question for nuanced judgment, and an agent handler that spawns a sub-agent with its own tool access. Start with command. Reach for the others when the decision needs more than an if statement. Here is the whole contract a command hook lives by. It's exit code. Exit 0 allows the tool. Exit 2 is the magic value. It blocks, and the message on std error goes back to the model as the reason. Any other code is logged and ignored. 6 lines of bash enforce the $500 cap that the prompt could not. Hooks are not a replacement for the prompt. They are the last layer of 3. Layer 1, prompt guidance, soft and dashed. Layer 2, the tool description, medium strength. Layer 3, the hook, a solid backstop. The 750 refund passes through the first 2 and bounces off the third. Defense in depth, each layer catches what the one above missed. One caution before you ship hooks. A hook is your code running with your privileges. It can read and write your file system, open the network, which means it can exfiltrate, and read your environment variables, including API keys and tokens. Treat a hook script like any other privileged code. Review it, pin it, and never run one you have not read. Last rule, and the most important. What happens when the hook itself errors, crashes, times out, returns malformed JSON? 2 doors. Behind the first, silently allow the tool. Your policy just evaporated and nobody noticed. Behind the second, deny and log loudly. Fail closed. Always take the second door. A guarantee that disappears on error was never a guarantee. Prompts are suggestions. Hooks are guarantees. Deterministic code placed at the right lifecycle event that fails closed. That is how the agent loop honors a rule it cannot talk its way out of. Next, the surfaces where these hooks live: Claude code and the agent SDK.